So I will now leave the floor to our first speaker, Debora Puglia. So Debora is Associate Professor in Material Science and Technology at the University of Perugia. Her main research interests are related to the study of biodegradable polymers and nanocomposites for application in the food packaging and agricultural sectors. She has been technical responsible of different European research projects and member of the technical staff of the European Centre for Nanostructured Polymers. She's also FURIOS project coordinator, and she will present the FURIOS project. So thank you, Debora. The floor is yours.
Thank you, Mara, for the introduction. So let me firstly thanks Elvira for being here. Thermofire is our sister project, so we were funding together. We are today discussing about our project. In principle, what I'm going to do now is to give the overall view of our project. So what is Furious and why we have such kind of project? It was funded in 2022 by the ECBJU, and this is our consortium. We are a list of 14 partners coming from different countries, and we collaborate together to have new furan-based polymers for very, let me say, stringent and niche application in specific sector that are, let me say, far away from the standard application in packaging. These are the details or where you can see the content of the project, and we started 1 year ago, and we are just now at the month 18 of the project itself. So why Furious? What is the ratio of doing Furious? The first idea is to go over what we can do with the furan weights. In principle, the most well-known polymer from this family is the polyethylene furanoate. We have some benefits, but even here some drawbacks. So we can try to substitute the PET by using this polymer for the high thermal stability, for the high thermal behavior, for the good barrier properties in comparison to the one coming from petroleum. But we have some limits in the use of this material. So one of the main problems is that PEF is stiff and fragile. What we would like to do in Furious is to try to cover different applications in the sense that we want to extend the processability of such kind of polymers in different sectors by using also different processing procedures. So one of the main issues is to try if we can use the monomer that should be used for making furanoates, the FDCA, if we can use directly, or we have to use the ester coming from this acid. This is a complicated issue that we are working on. We are working just now on elaborating the preparation of new families of polymers, starting from the acid and the ester. The provider of the monomer in our consortium is Enzo, that is giving us the monomer prepared by using their specific FuraCure approach, that is a patented method that they use to elaborate the preparation of the FDCA by avoiding the presence of some byproducts, such as humans, for example. This is what we are using just now. If you go to the YouTube link, you will see in a funny way how to make polymers by using FDCA. What we do in Furious, that is the acronym for Versatile Furan-based Polymers for Strict and High-Value Application in Packaging, Automotive, and Underwater Environments. What we would like to do is combine processing and materials at the same time. So we realize that we should investigate new methodologies to treat these new families of polymers with, let me say, unconventional methods that has to be tried with this polymers. So we want to use electrospinning and stereolithography in parallel to the, let me say, the standard one, such as in the case of injection molding, cast blow extrusion. I want to verify the end of life option for this material by using different pre-treatment. In our case, what we want to do is to use the gamma radiation to break the chains of our polymers. So the idea is to find an alternative to the already available furanoid base material, the PEF. So the idea is to go into the market with 6 different prototypes. So the markets that we want to cover are the biomedical and the electronic packaging, to tune the stiffness and to have toughness in a variable manner, to have rigid and flexible materials. Then we want to test the automotive sector. So we want to have electrospan filter and one injection molded screen. By looking at the functional properties of these products, only searching the property in the polymer itself. So we don't want to use any additive in the polymer. So the antibacterial properties and UV resistance should come from the polymer itself. Then there is the last application in the underwater sector. We want to have a new cable, biodegradable in the sea environment. And another idea is to have a scaffold that we can elaborate starting from a specific microscopic structure that should keep the microorganism on the surface and cone them. And we should elaborate specific surface properties for this polymer. The state of the art is completely different from what we are going to do in Furious. So in the case of biomedical packaging, for example, the polyolefins are poor resistant to edging. They go under cross-linking when they are under gamma ray radiation. In our case, we already demonstrate, and my colleague Nadia will show you that gamma is good for our polymers, so we can use them in the limit of the sterilization, and we can also try to break the chains to make degradation of these polymers. Then the antibacterial properties will have this property without incorporating any metallic or metal oxide nanoparticle inside, and we are going to test the electrospinning of these materials. The other idea, the last idea, is the one of making the scaffold for the underwater application by using less stiff polymers, or we can go back to the hydrogels to mimic this product, but we have to do it by using the polyesters coming from Furious. So we have many different objectives. I want to give you an overall look to these objectives. So the first two that we have already reached in our project, in our first 18 months, is to have an high purity monomer, since we need to have high purity to have good polymers. So this is already well done in the project. And then we are now elaborating new formulation for the preparation of the different polymers for the different application by using two different approaches: the homopolymerization, the copolymerization of different polymers. You can find on the right of the slide all the partners in the consortium that are collaborating in reaching the goal of these two objectives. Then we would like to develop and validate the the sectors of the automotive. Specifically, what we want to do is to have polymers that can be processed in melt and solution. So we want to make electrospun materials, and we want also to inject this product by having high glass transition temperature. That is not easy with such kind of polymers. Then, for the last application, as I said before, we need to have a rubbery material that should go in the sea environment, stay there, and we should check and tune the biodegradability of this product to find a solution for the state-of-the-art rubber that are now used in the sector that are not biodegradable at all. The validation is made by the company involved in the sector. So in the case of the automotive application, we have the Lippert partner that works together with the Italian consortium for the material science. Then in the case of packaging, we have the help of the different research institute, and the Gammaton is the Italian company that make gamma radiation in the frame of the project. We also would like to assess the end-of-life opportunities for this material. So we want to make chemical degradation by ionic liquids and diprotectic solvent to recover the initial monomer to make again polymers by using the same monomer, and we want to test the compostability. In this case, we want to have also specific degradation, hydrolytic degradation in sea environment due to the specific microorganism that you can find there. Lastly, but not less important, is the way that we should use to share our results. So we should maximize our communication, dissemination, and exploitation strategies, and this is done by the help of Nania, that is the company responsible for the realization of these objectives. So this is the general overview of the project. Let me share with you the first photo that we have taken together our kickoff meeting in Perugia. So this was the overall presentation of the project, and then Nadia will follow the presentation of the Furious project by taking into details what we achieved up to now in the different objectives. Thank you.